Okay, I'm off to a great start. Hey Phobos, thanks for being here. I see you're in the Discord. Okay. We're live on YouTube too. Okay, good. Um, so yeah, this is hey Stuki. Trying to make sure you don't mess up voice chat. No worries. I expect the first one will be a little bit like messy, and that's okay. Oh, you know what? I don't know how to OBS. I feel like but we've all known that for a long time though. This is the book that we are using. It's a little bit too hard for me to show it on stream at the same time as the Discord, so I'm just gonna not. But yeah, I figure we can take the first part to maybe talk about maybe the content or any questions we had or anything like that, and then we can get into the actual questions at the end of chapter 1. Let's just start dragging people into the call here. Hello, Phobos, Phobos and Stuki.
Hey yo.
Hey, Milk. How's it going?
Not bad.
Awesome. Let me get links to both of your channels in chat here.
Shit.
Hello.
Hey, Phobos.
Hey yo.
All right, so if anyone else wants to join, please feel free to just hop in the waiting room in my Discord. That's in the voice chat. People are also welcome to just type along in the Twitch chat. So yeah, I guess this is the first time I've been on a voice call with you, Phobos. Maybe we should just each introduce ourselves at least for the benefit of Twitch chat as well. So obviously I'm Don. I'm yeah, I know. I thought this reading would be kind of fun because it's very like applied, and I think there's a lot of existing interest in pure math. So this may be a nice like way to appeal to like applied math. Do you want to go ahead and introduce yourself, Phobos?
Yes, I'm Phobos Stream. I'm interested in electricity and magnetism, simulating the equations and that sort of stuff, which is why I really jumped on and read through the chapter material real quick, and hopefully I have enough knowledge to be useful at all here today.
I hope the same for me.
Same for you, Don. All right. Just 1 second, though.
Oh, sure.
I'm noticing there's quite a distinct echo when the Twitch is playing and the Discord is playing.
Oh, true.
I don't know who's actually making the echo happen.
Oh, I thought you said like the stream open and the Discord call open. Or is there an echo that's actually playing in the stream itself?
I'm not sure.
Um,
When I play both, I hear everything several times. But that's just might be me just doing stuff. You don't hear an echo.
people in chat are saying it's okay. Yeah.
All right.
Yeah, I've gotten used to turning off the stream audio for these things.
Okay. Pro tip accepted.
And hey, hello, Jenny. So yeah, Suga, I guess, do you want to introduce yourself too?
Sure. I'm not sure what to say. We're here on Twitch. My background is in algebra and combinatorics. But I took E&M when I was in college, and I dropped out of the class because I clear was not going to pass it. And I haven't thought about it since. But it's like an opportunity.
Well, it was a delightful surprise to see that you were interested in it. So, yeah, thanks so much to both of you for being able to hop in voice too. Because I feel like it's a lot more fun if we get to like discuss things as a group like this. And hey, Fedbucks. So, I don't know how you two are both feeling about like kind of the content of what was in chapter 1 before we even like try any of the questions, but let me see. I think there are some things that maybe I wanted to get other people's opinions on, and I don't know if you all had something that you thought might be nice to discuss. Let me
I
look
got just a
back.
couple things that were curiosities, but they're written on notes somewhere. All right. In section 1.13, I don't know if we want to jump right there from the start, but
Yeah, sure.
I found the end of it extremely confusing. They derived the electric field around an infinite plate, and then they started throwing around qualitative words like, imagine you have a squat plate, and then imagine what happens when that happens. And I'm like, well, firstly, what's a squat plate? Secondly, what?
I found this super confusing too.
All right.
I had to read it a few times. I think I kind of know what they're trying to say, but like I'm looking for what the point of it completely is. Like they're talking about the discontinuity with just like a surface sheet of charge, but they didn't do a very good job explaining it to me, at least.
Yeah, I'm also not sure what discontinuity means in that regard.
I think actually, I guess maybe I can draw my impression of it on the Discord whiteboard here. Do you know how to get into the whiteboard?
Me? No, I do not.
Shoot, I should have said that. So, in the Discord call, you might need to like click on the live voice channel. There should be like an activity called whiteboard. I think this might be the easiest thing to use, but there's also like website of keys that might be easier. If you can't find it, or even at the bottom of the Discord call, there's like the little rocket ship button that's for the activity. Oh, I might have to give you guys permission. Shoot.
I'm not allowed. I'm not allowed, Don.
Yeah, I forgot about the permissions.
Yeah.
I
Well.
think I can make it quack though. Is that what we're doing?
That's not bad either. Shoot. Okay, I think I can fix this quick. If not, we can always just use Excalibur or something. Okay, use activities for everyone. Okay, are you able to use it now?
I don't think so.
Okay. Huh. That is annoying. I remember Zach had the same exact issue that first analysis class.
At your discretion, I can leave and come back.
Um,
That's a last resort.
I don't think that'll do it. I'd have to set up like a new role, I guess, and that sounds annoying. We could just not be in a lock. Like, we could just all go over to Lounge 1, I guess, if you guys don't mind. That one isn't locked. We should be able to do an activity there.
No problem.
All right.
Oh, wait. Oh, all right.
Okay. Let me get this set up.
Okay. Yeah,
That's
that works. So it's really just like in the locked channels that you have a problem.
Yeah, so
Interesting.
yeah, I'll just figure out a role for next time that we'll let you guys do it. Okay, so hopefully we can all see the whiteboard.
I confirm I see it.
Okay. Oh, shoot. I'm just giving a title to the board. E&M Chapter 1. Part 1. Okay. Nice smiley face. Okay. So I was interpreting this as like Ooh. Oh yeah. If you have that infinite sheet of charge, that's gonna be a terrible drawing. But basically, on one side of the sheet, the charge goes like out to the right, and on the other side of the sheet, it suddenly goes out to the left. And I think that's the discontinuity, where as soon as you cross over the sheet, your field suddenly changes direction. And they're making the point that or the whole stuff of the perpendicular is that this continuity only happens perpendicular to the sheet. If you have like another charge here, only the parts of this thing's field that are perpendicular to the sheet are potentially affected, like as this one part of the field crosses over. Like ones up here that are parallel don't get affected at all. I think that's what they're trying to do, at least. I don't know if that makes sense either, but
Makes sense.
yeah, I still don't completely understand the way that they actually like went about that in the book, but that's yeah.
I can accept that. Oh, but then qualitatively, they describe it as a squat sheet.
Right.
What exactly would that be? Did you shrink it from being an infinite sheet to a smaller square, or is it like get thinner? Like, in what dimension is it squat?
I think it's a very short like cylinder that they're drawing onto this plane, so like the sides of it are short, but it's still like wide at the top and bottom. And that's so it's like less affected by the charge that we've added. Oh god. And I think they're doing that so like the field from this charge, it hardly affects the sides of this like cylinder. At this point we can just call it 0, but that's how I was interpreting the squat part. Oh yeah, we can find the page.
So that would be next to figure 1.26 on page 29.
Right.
Yeah, a very squat Gaussian surface. There we go. So yeah, I was also confused by that, but I figured that's what they mean, and when they say, or when they're like worried about the sides of the pillbox, that they call it, I guess.
Also, pillbox. Is that just a short cylinder?
I guess so.
Yeah.
Yeah.
English is apparently my first language.
No, this part was very confusing to me. Like, I think I figured out what the point was, but it wasn't clear to me at all. Yeah, I'm glad I wasn't the only one who was weirded out by that. I'm saying it'll look more like the surface of a quarter than or a dime. Yeah, I guess so. That's like the shape it'd be. I'm trying to see if there's definitely another part that was unclear to me. I'm trying to remember what it was though. Oh yeah, actually, it's what Milk is saying. For an infinite sheet, the charge field is uniform over all the space. That's just kind of a crazy fact to me. Like I can accept it, but the fact that the field of an infinite sheet doesn't depend how far how far away you are from the sheet is kind of crazy to me. Like it just doesn't get weaker.
Yeah.
I think that's really cool, though. And I think
It
that
is,
comes
yeah.
into play when you have electric components like capacitors, which are effectively at a very small scale, infinite seeming sheets next to each other with differing charge.
Oh, that's interesting.
I don't know how well the physical reality maps into the infiniteness suggested by these equations, but that's what it brought to my mind.
Yeah, I think the book made that point somewhere, or like a similar thing, where if you're close enough, it seems infinite. Okay, I can't remember what else I wanted to ask about, but if there's, are there any other things that you all would want to discuss, or do you want to get into the problems, or?
I mean, yeah, I didn't have anything from the text. Although, I mean, I can't claim to have read all of the text.
True. Yeah, that was a little bit unlucky with that book mix-up. All right, so I got screenshots of the first. Actually, I got screenshots of like probably half the problems. There's 80 something in total though. I don't feel the urge to get through all 80 something, but I figure we can see how many we can get through today, and then maybe next Saturday we'll do another session and get through some more, and then we might feel confident enough to move on. But I don't know, we can see how I feel at the time. So for lack of a... Where's my... What? Oh no, don't do this to me, Discord. I'm trying to bring in the first problem. I'm not getting the pop-up that I'm expecting though. Where is it? Oh no. I haven't had this problem before. It's not letting me bring an image in.
It's like stuck.
Yeah, I hit the image to add or I hit the icon to add an image, and it just says selecting image, but nothing actually pops up to like select the file like it normally would. Huh. Well, that's annoying. What if... Let me leave and rejoin the call quick. Okay. Now is it fixed? Hey, there it goes. Okay. Just in case enough things couldn't go wrong. There we go.
Oh, good. And it also doesn't show on stream, which you probably knew by now, but I was a little bit concerned about it.
Oh, like my all my files, yeah.
Yeah.
No, I didn't think it would at least. Oh. Anyway, hey, Saint Just Germany, welcome in. 1.13. Yeah, the book did say that about the infinite sheet somewhere, that like the vector contributions become more and more. I forget exactly where though. Okay, so... Oh, you know what? As a quick aside, the book, they give stars to each of the problems, and I believe those are difficulty ratings from 1 to 4. And I think 1 is the easiest.
Good to know.
And it starts off with problems that seem maybe a bit more theoretical, and then there's exercises that are a bit more calculation focused. So these are problems.
Yeah, that
First.
was weird. I thought that was a little weird that it's like there's 2 sections of exercises.
Yeah.
Is there any particular focus we'll have? Problems versus exercises.
I think we can do whatever seems interesting. Like, I'm just choosing the first one here just because it seems to make sense to at least do the first one here, but we can like bounce around all we want. Oh, and the book only provides answers to the problems, but not the exercises, as Fembox points out.
Okay.
Actually, we should maybe start in the upper left corner. I remember that's another lesson that we learned in the analysis class. So you might need to zoom out a bit to find it again, but I dragged it all the way to the upper left here. Okay. So the problem was this: gravity versus electricity. In the domain of elementary particles, a natural unit of mass is the mass of a nucleon, that is, a proton or a neutron, the basic massive building blocks of ordinary matter. Given the nucleon mass is 1.67 times 10 to the negative 27 kilograms, and the gravitational constant g as 6.67 times 10 to the negative 11 meters per kilogram second squared. Compare the gravitational attraction of two protons with their electrostatic repulsion. This shows why we call gravitation a very weak force. I'm sorry, Saint Just Germany. He asked a philosophical question about math. Right now is not a good time because we're doing this kind of discussion right here. If you want to hang around until after we're done with this, though, I'm happy to talk. So yeah, for this, I think Milk is giving us the key equations here.
Yeah, I think that's correct, but then we only want one charge or one mass in our equation, so it would give, what would it be, not the force, not the field of force, but something else. I don't know what it's called in terms of gravity.
Well, don't we have two protons here, though? Or...
Oh, it's two protons?
Yeah.
Okay, I thought it was
okay.
a general one proton system.
I bet you could do it in that sense too, but I guess we can stick with what the book says. So I guess if I blindly copy down what Milk is telling us here. G m1 m2 over r squared. And comparing the ratios, that seems like a sensible idea. Because our r squareds are going to go away.
Right.
So yeah, I guess let's divide them. F sub e over f sub g. K, Q1. What's up?
I'm thinking about Q's.
And G, M2. And I guess we're gonna have to do some calculator work here.
I'm also looking for the value K in here somewhere.
Yeah.
I think that's in section 1.4, 1.3.
Yeah, it's like 8.988 or something. And we're gonna have to, I guess, get the Q in terms of coulombs of a proton. I think they say that too.
This is all like around page 8.
Okay.
Is that what I mean?
8.988. Oh gosh, that's not an N. They give us G as, I mean, I don't know if the units are even important here, but 6.67 times 10 to the negative 11. Oops, I forgot. Oh, it's an important part of K. Do you remember what the exponent for K is, or like times 10 to the what?
Oh, right. 10 to the 9th. I'm
Okay.
sorry.
No, it's all good. And then the book, I think it said somewhere in coulombs the charge of a proton. I'm trying to find that.
Yeah. 1.602.
Oh yeah, please write it. It go there at.
19. Yeah.
Oh, it's a table of useful constants on the third or fourth last page. Okay, nice. Okay, I like that. And then we have the mass. 1.67 times 10 to the negative 27. Oh wait, what's the units for G? mkgs squared. And then
1.67.
yeah, 1.67 times 10 to the negative 27.
There. Kilograms.
Yeah. All right, and then I guess this is the job for Wolfram Alpha. Going over there now.
Look at the exponents of the
Oh,
minus
true.
10. Great. And make sure you have the right units. I forget how to turn newtons into kilograms. I should know that.
Oh, what's mass and acceleration? So k m over s squared, or kg times m over s squared, right? The box is saying yes. Okay. On top we get 10 to the negative 10, whatever units. And to the negative 38?
No, there's an
Oh,
extra 19 that we need in the top.
oh, true. Forgot it squared. So 38 minus 9, 29?
Looks good.
Then 27 times 2. 54. And then negative 11. Oh, wait, does it? No, never mind. I was about to say the negative 19 squared turns positive, but it's not. Okay. Never mind. 54 plus 11, 65?
Yeah.
Then I don't think units are even important because it's a ratio. I guess it's going to be unitless, isn't it?
So.
Oh yeah.
We should expect to be unitless, I think. Yeah, because this kg will cancel with one of those kgs. The other kg will cancel with what's inside the Newton. They're both forces. Okay, yeah. I was gonna say that the units cancel because that's easier. Okay, you know, I'm just gonna type the last of this into Wolfram Alpha. We're expecting a very big number, I would think, right? Because we did force on top, or electricity on top. 10 to the minus 29. 6.67. To the minus 65. It's 1.35 times 10 to the 36. So
Okay.
almost there.
It rounds. I'll allow it.
Yeah. Take the ceiling.
Well, there's a method of rounding that prefers to round in very weird ways that turns out to be more accurate. Get a
Really?
chance. Look up round half even.
Round half even. Okay. It's like you could potentially round 1.35 up to 2?
I forget the exact rules, but
Oh,
there's an
okay.
analysis in a text that I had read. I was surprised. It's like, really? Why would you round like that? Because it's more accurate.
Huh, that's fair. So I guess either way, we're getting the force due to electricity is, 10 to the 36 times greater than the force due to gravity, which seems like a pretty big difference. So I think that's what they want us to do for part A.
What's that saying? Is that saying that the force of electricity is like 10 to the 36 times stronger than that of gravity? Also, am I accidentally pasting this? Because this is
Oh.
text I typed. And I don't know how it's pasting.
I don't know either. There's like a duplicate thing, that like third icon in the bottom center. So if you clicked on that, it might... That might be why. But yeah, I guess what I was saying is, at least for this situation with 2 protons, the force due to electricity is way greater than the force due to gravity. But maybe if we repeated this this calculation like planets or something, we might find a different result. Because I guess those would have very little charge, or to be nearly 0, probably, I assume. Maybe you should label this as A. Planet is close to neutral? Okay. So part B says the distance between 2 protons in the helium nucleus could be at one as much as 10 to the minus 15 meters. How large is the force of electrical repulsion between 2 protons at that distance? Express it in newtons and in pounds. Oh, pounds, okay.
Pound.
I don't know how that conversion is going to work if it's not gravity. I think maybe, I don't know. Even
I
stronger
mean,
is...
he's still a force.
Okay, that's fair. I'm just bad at physics. Even stronger is a nuclear force that acts between any pair of hadrons. They're close together. Pounds is still a unit of weight, as is newtons. Okay, fair. So I guess we can do part B like right there-ish. Slugs are mass and imperial? I've never heard of slugs as a unit. Distance between 2 protons. Okay, so I think this one is going to be plugging it into Coulomb's law. Do either of you want to try it? If not, I think I have an idea.
I have to look up that equation. I think it's the one we used to start the derivation process of the last answer, but let me check to be sure.
I think so, yeah.
All right, so that should be... I'll give it a shot, I suppose.
Go for
They're
it.
asking about the force, res, so that would be force, numeric, non-vector, is
Yeah.
k times charge 1 times charge 2, and this will be the same charge. We don't have to worry about the vector in the numerator, but we do need to worry about the radius squared. All right, so then k would be the same constant we had from before, 8.988 times 10 to the 9th. What's the courtesy on writing all the units? Is that advised? It's been a while since I've done
I
done
guess we can.
physics.
Yeah, let's do it.
That was for now.
Okay, and then they listed the charge. They list the charge somewhere.
No, we got it in green up above.
Oh, it's in green up above, and that's this one?
Yeah.
Okay, I can do this. To the negative 19th square. And we've got, what is it, 10 to the negative 15th meters between them. Yes, 10 to the negative 15th. All right, and that'll be squared. Got my units on the other thing, but that's fine. Okay, then I will continue downward, I suppose.
Sounds good.
Need a calculator. Turns out, immediately. I look at the numbers, it's like, yep, calculator. Let me find one. I'm not prepared. We've done the squaring before, right? Have we done that one yet? I see a 1.62 here.
I can just plug this entire thing into Wolfram to simplify things.
Yeah, that would help me out a ton.
9.
Unless
times-
arithmetic's part of the challenge.
This would be some. If you can do this mentally, I'm impressed.
All right, let me at least try to think of
That's
an
nice.
approximation. So 15 squared would be 225.
It's 15. Okay, I do have an answer from Wolfram, but let's see how close you get.
Yeah, do feel free to start writing it while I continue my estimation.
Sounds good.
Yeah, no, I didn't do that.
Oh, yeah. Where did
But I
that
got
squared?
about the same prefix. So for
Okay.
me, I had I ended up with the negative 29 that we did from the previous part, and then negative 30, 10 to the power negative 30 in the denominator. And I figured they would cancel all but about one or two of them, and I chose two.
Hey, at least you got the first part pretty close. Well, awesome. Um, I guess that's good for part or for number one part probably.
False down pounds.
Oh, pounds. You're right. How do we convert from noons to pounds? uh, hey, Dr. L.
Sweet.
Sorry.
Sorry, what's the reasoning on the exponent?
Oh, did I actually do the exponent wrong? I would believe it. 10 to the negative 15. It's entirely
Do I need to
possible.
estimate for real?
Did you square 10 to the negative 15?
I sure did.
Oh my god.
Mm.
That's the problem. My bad. Actually, yeah. So 2.31 times 10 squared.
Oh, hell yes. I take it back. How do I
Yeah.
uncross something out?
My bad. You might be. Oh yeah, you can just click on the line and it'll select only that line.
Nice.
Oh my god.
I believed in myself the whole time.
Yeah. Turns out calculators are wrong. At least I use them
All
wrong.
Phobos. You need mental math done.
um.
Yeah, I get about 52 pounds for this.
52 pounds. Okay. I was about to try to work out the conversion with the actual units, but that's easier. Was it 52 pounds?
Yeah.
Okay. So us Americans can understand how big this force is. Between two protons, and for such a small scale, that does feel like a big force, I guess.
Does, yeah.
Just two protons that are kind of close together.
And then Milk and Horns was mentioning the propulsion is quite strong, but then the nuclear force is even stronger.
Right.
Which is amazing.
Yeah. I have heard of the strong force, and I know that, like, it helps hold atoms together, but I don't know what it actually, like, is, in the sense that I know what, like, gravity and electricity and magnetism kind of are. But it's sure
There's a
there.
relevant XKCD about this.
Oh, that makes sense. And just for you, Fembox, you're right. I should do a curly L. Pounds.
Resident degenerate webcomic reader.
I gotta see this. Forces between particles, gravity, magnetism. It obeys well. It holds protons and neutrons together. that sums up my feelings on it so well. No cool those last two are. Okay. I guess I'll drag in number 2 then.
Yeah.
Seemed like an interesting one when I was looking at it earlier. Let's make a little border.
Oh yeah, this looks like a Zach problem.
There's an example in the book that showed a stable point in an electrical field with some static charges.
Yes, I remember that. I guess we want to make a similar drawing here.
Probably want to do math too. Maybe. Hopefully, it's possible.
Oh yeah, the numerically part, I'm still not quite sure how we're going to do that, but...
The figure's
Definitely draw a
on
triangle.
page 19.
Okay. I see Dr. L's putting an example problem in there too. I think I'd be plugging into Coulomb's law, right? We're given each piece of information we need. And fourth ion be placed. Okay, so I'm a little bit caught up on the symmetry axis part. I guess the symmetry axis is like a line through just one of these points in between the other two. So like that will be a symmetry axis.
Yeah.
Actually, I guess would this count as a symmetry axis, or does flipping the positive and negative charge break symmetry? It might not
Yeah.
matter since they're arbitrarily placed.
You're thinking that if you have some like positive charge that's sitting here, here for instance, then the like horizontal component is from both of these is gonna cancel each other out. Whereas, and then like the negative is gonna, but since it's on the right line, but then if you try to go the other way, the negative charges or the opposite charges are going to work against here, right? So if you have a positive charge here, then the positive is going to send you that way, but the negative is also going to send you that way.
True. So yeah, I guess those axes don't even matter because you're not going to be able to get the zero force there, no matter what you do.
Yeah.
Force on it will be 0. And so you were suggesting putting a charge down here, or was I misunderstanding? Okay. Because there's still like this like vertical line that you just drew. Because even the positive charges are canceled, we still have that vertical line field from the negative charge that I assume would still be there.
For sure, yeah.
So the field there, I guess it's not 0.
For me, I would actually think of the 2 positive protons as being inside of a circle, and the charge exerted from that circle. Shouldn't that effectively be modeled by a point charge? So you could think of this as just 2 point charges. Or am I off base with that?
I think it's fine, but I'm not sure how you calculate distance from that point charge.
From the virtual one, that's
Right.
I think it would be just you consider it to have a charge of 2 being just in line with the negative charge. So you'd end up with a simplistic positive negative system, kind of like they have a picture on page 19. 19, yeah. And then the stable point would end up over here, or the zero electric field point. So not necessarily stable. But I don't know if that's valid.
I'm worried about the equilateral triangle constraint. Like I feel like this approximation is only good if the negative ion is sufficiently far away, but the equilateral triangle part might not let that happen. I guess like we could get the field of the 2 positive ions and then ignore the 2 positive ions, but I'm not sure.
I think Milk and Horns is pointing us in the right direction.
By writing the total net total field as a function of space, then solve for where it's 0. Okay. And the Lagrange points for gravity is kind of an interesting relation. I don't know anything about Lagrange points other than that they exist, but I do think that's cool. So I guess what's the field for? I mean, I don't know how we express how we represent the space, or if we want to write the total electric field, it would be we have to decide on a coordinate system, I guess. Like Milk is saying. So could we just put the origin at the bottom middle of the triangle?
Sure.
I'm messy drawing. And I mean, I guess we could only worry about the field on the y-axis here, right? Because we're worrying about the symmetry axis only. So that might simplify the calculation. Call it E sub y. I guess we're gonna need some trig here. If it's an equilateral triangle, our angles are 60. I'm gonna say Q1, Q2, Q3. That's kind of terrible. I feel like I'm not going the right way around the triangle with that. Let me... Q2, Q3. I don't like the negative ion being in the middle, though. It's just totally pointless, but I'm gonna... There. So we have minus KQ1 over... If we choose a point on the y-axis, so we call that distance h, and we're gonna have y minus h squared.
Yeah.
That, yeah, I don't know.
Agreed, yeah.
Okay. And then if that's 60 degrees, we're going to want sine.
But
Or, well, we can just, I mean, we can also do whatever we want, I guess, but. Yeah, I guess we really need that angle. Keeping in vector form might simplify things.
this is cosine. That cosine, is that how cosine works?
No, that's sine. I'm getting caught up on the same thing though. I don't blame you.
Okay, and I don't care about theta maybe, but
So that means r that we really want is y over sine theta.
right.
I think. It's a terrible theta.
And we know that. But we also, oh, hold on. We also know that this distance right there.
Oh yeah, we could call that whatever distance we want, right?
Well, we already know 8. So I think we have to write it.
Oh.
8.
Okay, that's fair.
But now we're going to need that 60 degree angle.
True. I guess we're going to want tangent.
H over root 3.
Tan 60 equals h over, I don't know what to call that other, we call it a over 2. If the side of the equilateral triangle is a.
Yeah.
Then we're solving this for a. Except I am unable to do mental math right now. 2h. And then tangent of 60. Root 3 over 2 over 1/2. So yeah, that's just root 3. Okay. So 2h over root 3. Or 2 root 3h over 3. So actually, do we even want to... Are there any solutions outside of the xy plane? They're saying the symmetry axis, so I was thinking... Oh. I don't think so, Milk.
No. Okay, well, maybe. I see. So certainly the x and the y components have to line up, right?
They have to line up, like, how?
Yes. So I'm imagining like the calculation that we're doing right now still essentially has to be done if you were to try to lift off the plane, because you still have to cancel. You still have to cancel the x and the y directions of the force. But I guess the distance will be different because not obviously in a nice way.
Yeah, I guess if it's zero force, it should be zero force in every direction.
Right.
Oh, hey Jed, 35, nice. I guess I was imagining like a third point that would make, what is it called, a tetrahedron? For like an equilateral triangle in 3D.
Yeah.
But I don't think that would be, like, there's no charge you could put there that would end up with net zero because of the asymmetry with the charges.
Yeah, probably.
But I guess you could, like, it doesn't have to be a tetrahedron. It could be some other weird shape that goes over there or something.
Right.
Hmm. Three forces can only sum to zero if they're coplanar. That'd be nice if we can just take that and run. XY plane is the only solution and it's unstable. Okay. I guess, so even if we follow through with this like E sub y thing that we're doing, I would say for following what the Milk was saying, we would set equal to 0 and solve for y.
Right.
I guess. Okay. I think we're nearly there because the field for Q3 is going to be the same, but the distance will be negative, maybe, or maybe it'll just even be the same. Because if the y component, we're just going to end up multiplying it by 2, I think, because we're not worrying about the x's.
Right. Same y, opposite x. I'm on board.
Okay. So how are we getting this distance between our positive ions in the y-axis? I forget why we're doing this tangent of 60 thing now.
Oh, we wanted the this this.
Oh, the distance from there to there. Okay.
Right. From the charge, positive charge to the y.
And that's helpful, I guess, if we down here with this triangle, so we can do tangent instead.
So then we can Pythagorean theorem. Yeah.
Oh, Pythagorean theorem. Okay, that's even better. Because then we don't have theta at all.
Sorry.
Oh, no. How's that going to look? It'll be x squared equals y squared plus... And the thing I calculated over on the right. I think I did a over 2 in the initial thing, so I think we're okay.
You calculated a though.
Oh, I did calculate a, and we won a over 2. Oops. Good point. There we go. And then get rid of that. Okay, so I'm just going to come over here and do the square root y squared plus 1/3 h squared. And then we can slap a 2 on it.
Don, do you know what I'm about to tell you?
That I'm wrong. I would believe you.
You forgot to square the radius again.
I forgot to square the radius?
Yeah.
Oh my... Ah, you're right. we could also make the claim, I guess, in magnitude that q1 equals q2.
Right.
So that might... I mean, they don't have common denominator, though. Actually, yeah,
We
these are
gotta
all the
solve-
denominators. How's the 0? Sorry, what?
We gotta solve for like when this whole thing is 0. So it's there's gonna be some messy quadratic that comes out in the end.
Hey, Waffle. Is there a value for y such that this thing equals 0, though? Y is stuck in the denominator. That's what I'm confused on.
I add the first term to both sides.
Oh, common denominator.
Why?
Or that, yeah. Okay, that's fair. Y equals infinity? I like it, Milk. Let's roll with that. That is a solution, though, isn't it? If we're literally infinite away. That shouldn't be negative if they're equal to each other. And we can just divide out the q1 and the k. If I make the claim that q1 equals q2. Because they're ions. So we get, unless...
We need to account for the sign difference, though.
I stuck a negative sign in front of the initial thing.
Oh, I see.
So I hope that is good enough.
Yeah, that seems...
Okay. I'm sensing the quadratic formula in our future. And this happens to clean up really nicely. 4yh plus 2h squared. Quadratic formula means 2 solutions, unless it's a repeated root or complex. Y squared minus 4y. I guess I should say 4hy. 2 plus a third. 7/3. H squared.
Yeah.
Oh man, I can't even make this Wolfram Alpha's problem. It's not gonna like the H's. It's probably not. So minus b. B is already minus. So minus b squared minus 4ac. So 28 over 3 h squared. That might clean up. Okay.
16 times 3 is 48.
Root 48, yeah. So 48 minus 28 is 20. Or 2. Oh. 4 plus or minus root 20 is 2 root 5. Oh, well. That looks kind of stupid, but it's an answer. So I want to get the values for this and see where this would land us. If that makes like physical sense. So we have 4 plus square root of 20 over 3 over 2. Oh, wait, there's a less stupid way that I could write this. 4 plus or minus root 5 over root 3.
Yeah.
Okay, so the plus gives us 3.3, I'll call it. 2 plus... I'm just gonna write a different way each time, apparently. 3.3. H. Then what's the minus give us? 0.71. Really? So these are both positive. But one is below H, one is above H, I guess. Yeah. So that means 0.7H is like right around there. And 3.3 times H is way up here. Sorry, I went back to the coordinate system that I drew before. That seems weird. It's the red circles that I drew that are my eyeballing. Huh. That doesn't seem right. Milk, yeah. The one inside the triangle can't be right.
Right.
Oh, really?
Yeah. I'm getting the same. I'm getting this this like stars and distances problem from back in the day with Jeff Groves, that vibe, right? Where if right the like actual in that setting the set of solutions was like a circle, and the circle passes through like the midpoint between, well, not the midpoint, but like somewhere in the middle, and then also like extends out toward the weaker, right? So here the negative is the weaker charge. In that setting, both were attractive forces, and here that's not the case. So that's something to be bothered by, maybe.
I'm
Point
still
seven.
working out some stuff on paper over here.
No worries. So actually 0.71 is 1 over root 2. That feels kind of meaningful to me, at least. I feel like if we do have two components from the positive ions being added up versus just the one negative. So it should have to be closer to the negative where its electric field gets stronger.
For sure. Yeah.
So you were saying? Yeah. We're the denominator for 2kq2. That came from the Pythagorean theorem on this triangle for any point on the y-axis, which, do we get a sign change depending on theta? Well, I guess we use Pythagorean theorem, so that wouldn't matter.
Right.
Our work is kind of all over the place, Fembox, unfortunately, but this tangent 60 stuff over here is how we figured out this top part of the triangle. Or the bottom part if we're above. I wonder, is there like a website that would model this type of thing? I'm gonna do a quick Google.
The sort of stuff I want to write simulations for.
Yeah, it'd be cool to look at.
I wanted to have
there are
one done
solutions.
before today, but
If you do, that'd be super cool. But it's up to you. Calculate the vertical component of those E vectors. That is what we did, Fembox. Or that's how we fit. Or. Ooh, is this. Did we get the
I think
total
maybe-
chart? The total field? Maybe we need to cosine or sine in there still. Sorry, what, Phobos?
I was just thinking about the use of the angle 60 degrees and if that's valid when we're thinking about setting up the equation to establish the electric field. Because the test charge is at some angle that might not be 60 degrees compared to the two positive charges. And I'm wondering if that affects the amount of charge felt by the test charge.
I was wondering about
Yeah.
that too. Oh, what?
So the only thing, I mean, sort of the way that we get the r squared is by using this. Yeah, I've drawn it upside down, that upside down triangle, but like the y, h, and half the distance between the two positives. That triangle. And the only trouble is that y is the variable, r is what we are trying to plug into Coulomb's law, and so we need to know what the other side of that triangle is, and that is going to be constant for anywhere we put the test charge, because we are only putting the test charge on the y-axis. So even though that theta is going to vary, that bolded line there from the positive charge to the y-axis, that is always going to be constant.
So I just partially spoiled myself, and I looked at least the diagram of the solution, and there is one above the triangle and one below the triangle. There's not one inside. So there is something off here.
All right.
Unfortunately. Yeah, I wonder if we... I feel like for like this Q1 bit, it should be okay. But I worry, like... Do we need something extra on the Q2 to get just the... Because we calculated the distance to R. I feel like that... Like, I felt like our calculations already accounted for only the Y component, but I guess not. Like, we could just slap a sine theta on that and then figure out what sine theta is in terms of Y and H. I might take a hard look at the solution just to get a better hint here. Oh, the first thing the solution says is, first note the desired point cannot be located in the interior of the triangle because the components of the fields along the symmetry axis would all point in the same direction toward the negative ion. Oh, right. I was thinking they were counting each other. They're agreeing with each other. Okay, that makes sense.
Okay.
Like the... yeah.
Yeah.
Consider they did let the triangle be 2 units on the side. I guess so, because they split it in half as well, but we can keep it as A. And P. Okay, so what they do is since they roll out, I'm gonna... Oh gosh. I feel like I want to delete all the work that I did on the bottom right there, but I'm gonna go maybe it's like the left side here. and just start a new sketch. Our sketch is actually like we happened to set it up in the same way that the book did, but they approached or where they went different is since they threw out the inside of the triangle, they just assume that there's one point above it and one point below it, and then got the distance to those, I think, separately. I'm still reading it though. Ignoring the factor of e over 4 pi epsilon naught. What? So they it's nearly the same thing that we did. It's just I guess the distances that we got are off. Beyond the side. Okay, well, the book focuses first on beyond the side containing the 2 positive ions. So the book focuses first on the lower point. And if we do our same... Hey, Mangoes. Thanks for saying hi. Hope you have a good day. Okay, if we let this side be A. Little E or F vectors in your test charge, that picture might help. I think I just have a hard time picturing the electric field in this situation, I guess. I think there is like kind of a intuitive drawing way that you can figure out vaguely where these things are. A over 2, 60. Three vectors, one for each of the 3 fixed ions. Oh, true, if it's just the y components. Okay, see, I guess it's where, like, the negative charge, or the force from the negative charge equals the force from the positive charges. If I combine the 2 positive ions into 1.
Right.
Three over 2A. That red arrow is a sum of two components. Right. So I don't know how like best to draw, but I could like put another arrow in the middle there to show that it's two vectors stacked on top of each other. No, y or negative y. Tell me what to do, book. Y plus root 3 from the negative ion. Oh, are they... Do they flip the y-axis? Is down positive y in the book's solution?
Yeah.
Yes? Okay. I guess we don't care about the orientation of the x-axis, but I'll write plus y minus y. And so the book has y plus root 3 because they give actual values to the triangle, but I think what we have is equivalent if we stick with our arbitrary equilateral triangle. I think it's kind of cooler. You'd have e sub y equal to minus k e is better to use than q because we know these are ions with charge e. So from the negative ion, that distance is y plus root 3 over 2a. Oops. Squared plus 2ke. Now distance from the two positive ions, we know the bottom of this triangle is a over 2. Is this part already different from the other part? Actually, yeah, okay. I know the construction is just different also, so I don't know if this is good or bad yet, but
I think maybe I see what Box is getting at here. And Phobos, maybe this is what you were getting at also. Like the
That coefficient in front of the a be a root 3 over 3.
maybe.
EY.
The height of this equilateral triangle. Well, Pythagorean theorem should agree. I'll try to do it with Pythagorean theorem too.
I'm only asking because I got a over 3, but that might not be correct.
Oh, Fenlux prefers those red arrows. I mean, I could, yeah, that is the actual, and then we take the y components of those. That's what Fenlux wants. I think it is root 3
right,
over 2.
and I don't think we've been. I think that was like what our big problem was, is that we didn't take the y component.
Yeah, I wonder if we could even modify our original thing. But I don't know.
Root 3 over 2 for real?
Actually, now I get root 5 over 2. What am I doing? Oh, I didn't minus. That's why. I should get. It's still, yeah, it's still root 3 over 2 when I do it either with trig with sine of 60 or with Pythagorean theorem for the height of this equilateral triangle.
I also get square root 3 over 2 now.
Okay. Awesome.
That was my bad, misremembering my signs. The whole time. The whole page is like this. Oh my god. think the bottom of the next fraction is going to be the a over 2 squared plus y squared to the 3/2 power, I think.
For 2 squared plus y squared to the 3/2. I'm actually kind of confused on what the book is doing. And then I don't know, like if we're just defining the vertical component this is y, wouldn't it just be y squared? But we would still need the vertical component. That's the problem. I'm sorry, what, Phobos?
Oh no, I think you picked it up.
So we're not finding the vertical component of the direction vector, we're finding the vertical component of the force. So we still need the radius, like the full radius, or the full like r squared. But then after that, we have to multiply through it, which is what I'm trying to do in red down here.
Someone said earlier that there were answers in the book, and you're all referencing answers. What page is that on?
587. Yeah. Same theta as y over r, and then I guess we know what r is. Oh. Times y over root, and that's where the 3/2 power comes from. Okay.
Oh, it got a 3/2? I was close? Hell yeah.
Or like the power of 3/2.
Yeah, this looks a lot like mine, and it's even got the y in the numerator there. Hot damn, look at me go.
Nice. Okay. Like gasp, I just saw it earlier. So yeah, that's equal to 0. And then we would solve this for y. Much less nice. Over 2a squared equals 2y over y squared plus 1/4 a squared to the 3/2. Oh, that's terrible. I think they just hand waved it and said that they solved it numerically, or
Yes.
okay. Yeah, I don't want to solve that algebraically.
Did they really say that?
Yeah.
Solve numerically or by iteration.
Okay, so if we take A as 2 like the book does, oh, let's give this to Wolfram. And hopefully the answer matches.
Ooh, nervous.
It's 1/4 times 4.
Yet, y plus, we're taking the books convention.
Yeah, so our A is there too.
But our y is their y.
Oh, I think so, yeah.
Okay.
That's a good point. I just have it typed in no. I can see if the first answer matches. Y is 0.14?
Yeah, so I think in the sine theta
Ooh, matches.
oh really?
1463, 1463 for the one below it.
Okay.
Yeah, we defined our Y the same way, so I think that's okay. Shep, yeah, it's physics. 1463. Degree 6 polynomial equation. Yeah.
Yeah.
Yeah, it's nice part about doing physics and not math. We get to not have to solve things exactly.
Eaton.
Problem 6. They're more challenging than you were expecting. Yeah, I thought we only get a few done so far. We're mostly on 2, but honestly, I think these problems, this problem is really fun. Just trying to figure it out is the hard part. Okay, so we've gotten the first answer. The second answer, we're redefining y again to be above the negative ion. And everything's basically the same, but it's minus root 3 in their case, or minus root 3 over 2a for our case. So I feel like we don't need to go through and do the same calculation over again. Unless you really want to see it, but the process to get the other point is the same thing, just we flip a sign in the denominator for the first. For like the negative ion. And then you get a different answer. I kind of want to delete this work. That was bad. I mean, maybe we'll just cross it out. Scale it down a little bit so it doesn't take up so much room.
Did you put this in Wolfram Alpha, Don? Trying to solve this.
For the 0.1463, I put the last line that I wrote into Wolfram with a equals 2. It happens to spit out the right y value. So I didn't question it any further, at least. Okay, I mean, are you also looking into something, or we feel comfortable moving on to problem 3, or how are you feeling?
I like it. I'll have to figure out the numeric approximation a little bit later, but yeah.
Okay.
I think I'm cool with the methodology.
Awesome.
Sort of.
Yeah.
Rough at the start. This is like the first one that I've done like proper. So it's like, whoa, how do I do trig in the first place?
Same. It's like I looked at some of these problems, but I was kind of intentionally not trying them that much until today. So
Come on, Don, you gotta roll in here and just crush it in front of everybody.
I guess maybe switch these around. All right, so I got problem 3 on the whiteboard here down below. Force from a cone. Charge Q is located at the tip of a hollow cone. An ice cream cone without the ice cream. Well, that's sad. Just a cone. With surface charge density sigma.
Wait a second.
Wait.
Is the cone surface charged?
Yeah, I'm confused. So there's a charge Q at the tip, but also a charged surface?
Oh, maybe
The top of the cone is
portion
cut
that's
off.
charged is separated from the actual cone.
Yeah, that part is dotted, so maybe that'll be the trick. The half angle at the vertex is theta. Or the slant of the height of the cone is L. Or the slant height... Okay, I misread that. I thought it was like the slope, but that didn't make any sense. What can you say about the force on the charge Q due to the cone? Oh. Interesting. See, I like what Milk is saying, where the force is straight up or straight down. I get the feeling, like, if you break this cone down into a bunch of rings that get slightly larger in radius, each one of these rings, the horizontal components would cancel out.
Right.
So, yeah, I don't think we have any horizontal field here. And that's even helpful drawing there, but force in the charge Q. Well, are they asking us to calculate it or just say something about it? It's vertical, that's something. Oh, we're not even removing the top half of the cone yet. Removing the top half of the cone is for part B. So for part A, it's the entire cone. Okay. Write a short essay about the force on Q. Maybe I'll take a very quick peek at the answer key and see if there's some integrals or some actual like numerical calculations involved, or if it's just qualitative. I mean, I don't even be actual integration that's required for this, but I lost my page. 587. Yeah. I see an integral in here for part A. Okay. Force would be maximum if theta is 0. We'd have a line of charge below our test charge, like a cannon. Really? I guess that would make the distance shorter. You'd only have vertical distance travel rather than a slanted distance. Hmm. Maybe the integral you saw is related to your ring idea. Calculate the force due to each ring and integrate. That seems reasonable. Oh, and that there's Coulomb's law with um like the integral version, right?
Right.
Okay. So I guess maybe just integrate the whole of the area at once. Because this is a surface charge, so we're not doing the volume thing.
In the section about charge distribution, I think it is that about spatial charge distribution or surface charge distribution? Because in section 1.8 is where they talk about those charge distributions. They're talking about volume integral, and that doesn't seem like what we want.
I agree.
Yeah.
This feels like a polar integral as well. Well, I don't know. Either way, there's gonna be some difficulties with the calculations, some kind of thing we have to account for. We just take an arbitrary ring. Volume charge and surface charge are similar, just surface has a 2D integral instead of 3D. Charge constant sigma is units of charge per area. Okay. So I guess we probably want to like start by figuring out what's the force from just like one point on this ring. And then with integration magic, we can rotate around the circle.
Right.
So we could attach a coordinate system here. Theta. Q, and then I guess this would be some portion of L. L minus like L prime or something. I'm not sure how to call that quite yet.
I see.
Well, okay, I guess I'm going back and forth. What do we want? Maybe we want the circumference of the circle. We don't want circumference. No, you would integrate circumference to get surface area.
What?
I don't. I'm trying to figure out what we actually want. Like, do we want if we're just thinking of one of these? I don't know. I my mind is going in too many different directions right now. I was trying to cut straight to the chase of getting the entire circle at once, and wondering whether I want the circumference or the area. But the area doesn't make sense to me. The circumference, neither of those make sense to me right now. I guess maybe I should just focus on like that one point, like I was saying.
Right.
I definitely need to practice these kinds of integrals.
Same.
Sitting here like, and if I ... and then my brain does nothing. I'm like, you're supposed to find like a surface area or a value. My brain's just disobeying me.
Yeah, it makes sense when I follow along with the book's explanations, and then when I actually try to do it on my own, it's like, what? So, I guess this point here is we want the y component of the field from it. Hey, is that Phantom Jr.? If I'm pronouncing that right? Welcome in. So, sorry, what's up?
I think Milk and Horns is pointing us in the right direction, and I think one of the sections in the book actually does calculate force due to a ring. And I was looking for it. To follow
Oh,
along.
that sounds familiar. Yeah, it was one of the examples, right? Let's see. Maybe it was the hemisphere.
It was the hemisphere, thank goodness. I went through the chapter like 8 times now looking for it. God. I find PDFs to be hard to navigate because it's only linear. In a book, you can do whatever you want.
True. Cross section of the ring. Yeah, maybe I'm thinking about this a little bit too simply. I mean, I guess the hemisphere is 3-dimensional, though. We have a surface that exists in 3 dimensions. I guess we want to calculate, maybe not the one point like I was saying. Maybe we want to calculate for the little patch on this cone. Like a patch of area.
I think that's true. Maybe I was wrong about ring in that example. But it said ring. That means it must 100% always be related.
Or
That's a lie.
I think it can be a ring too. But like I guess like I don't know how to describe it, to be honest. It's like I don't know.
To be
Yeah,
perfectly
like
frank, I don't know the surface area of a cone.
Oh, yeah, it's a kind of a weird formula.
it is a weird feeling.
It's like
So surface area is pi times the radius times the L plus the radius again. Terrible. S surface area equals pi times R times quantity L plus R.
Yeah. Um I'm gonna do a separate drawing because I'm gonna get a little bit messy in this one, I'm sure. If we tried to, yeah, I guess making the ring thicker is basically what I was thinking. I see now why you were like bolding it more. So it's like we're taking like maybe more of a strip, or which is also a ring, but
Right.
so we would have like the width of that strip is DL. We're gonna have a theta and then oh god, and a d theta. Just terribly drawn in. And then we'd have a vertical change, which I don't know if we have a vertical height defined. I guess we could put it in terms of L though. Theta L. There isn't any d theta. That's true. That might be why it's a surface. But I mean, there is a different. Well, you're right. There might not be a d theta. So I want L times cosine theta for the height of this triangle. Oh god.
Want height of this triangle?
Sorry, what?
And we want the height of this triangle?
I assumed it was going to be helpful. Like, that's what we're going to have to integrate over?
Part of my derivation is requiring it to think about the differential for this little piece of surface, but I don't know if you need it after it's all done. I'm not sure.
Okay.
Essentially, just to figure this out, I'm setting up, I'm finding two radii, I don't even know how to call it. Pick two heights inside the cone, and then find the radii associated with those to the cone, and then from that you should be able to find the area of the little strip. And then hopefully that tells me what the differential's like. And then should be able to integrate with that thing and the charge density. And sorry I'm not doing it on the board.
It's all good.
Doing it on paper.
It's awkward to use the whiteboard sometimes. Yeah, I'm having a hard time like actually saying why, but I feel like the incremental change in charge is equal to the circumference of the circle times the incremental change in L? Or maybe, no, that's the incremental change in area. I'm sorry, I need to put a sigma on that. For DQ.
I see.
So that would be a two-dimensional thing. And I'm just kind of thinking about it in terms of like, yeah, the L is like the thickness of this strip, and then you bring it around 2 pi r in a circle.
Yeah.
Okay.
Wouldn't that be the same for a cylinder? And then wouldn't that be problematic?
Ooh. Was that the same as for a cylinder?
So it's not obvious that it's a problem, but it's not the same as for a cylinder because L is at the angle. You know, it's not.
What if we had this? What if we had this cylinder? I'm just curious if we would end up with the same differential with height equal to L and the small piece. And it's only my brain just wondering if we can get the same differential for different shapes.
The difference might be how our R is changing. It would be constant in a cylinder, but we're probably gonna have to do some stuff with it to make it vary. So maybe right now it looks the same, but it will look different. But I feel you could use that same ring approach for like a surface cylinder with using rings.
Yeah.
Just your R is a constant instead. So I think as long as we're careful as with how we proceed in terms of what are we going to integrate in terms of are we going to integrate in terms of R? What are we doing the problem? We only have like L and theta. Okay, I guess I'm still not sure I got the idea of how best to address that question. When DL is small, I think it might be okay, but I share Phobos's qualms that Fenlock says.
We should be able to use that to derive the surface area of the whole cone to validate somehow, maybe. But that might be a step outside of the problem.
Yeah, what a way to verify it, though. You're right. DL. Then we could check to make sure it gives us what we want. And Lux will try it. That's good, because I don't know how I would do this. The DL is tripping me up. Sorry, what?
You just integrate, Don.
You just
integrate. You gotta believe in yourself.
Apparently. I'm just, how do we relate DL to DR? Sorry, what?
The way they throw around some integrals in the chapter makes me go, huh, all right, I believe you, but...
Yeah, I did a lot of rereading because they assume a lot of you to be able to follow it. R is a function of L.
Right.
Yeah, so I guess we know R is equal to L sine theta, and sine theta is just a constant. So dr is equal to dl sine theta. Okay, that's something. Dr over sine theta.
Oh, but that's a weird thing.
That's going to be the area of a circle, isn't it?
I mean,
well, sine theta. Yeah, we don't want the sine theta. Do we need to sub that too, somehow?
No, we definitely need a sine theta.
Okay.
I mean,
Also-
if you want to change it to like height, then or to radius of the cone, then you can eliminate it. But
And just a point of order, that integral has the same variable inside and in the domain of integration.
Oh, okay, fair. Prime. And I guess I could be even more exact and say that R prime is that length. Hmm.
yeah, I mean, this should finish off, right?
It does work?
I mean, I don't know. Depends on what working means.
That's fair.
Uh,
I was looking at the actual surface area of a cone because I forgot what it was before. Okay.
theta. R prime is L. Or, yeah, sine theta.
Oh, what? There's a formula for surface area in terms of slant height?
Yeah, that's the one I've been working from this whole time.
Oh, sorry. You said that before and I forgot. That's my bad.
But it did help.
Okay.
I'm still deriving parts of it, and it's not going well.
Okay. Pi L squared sine theta. Is that good or bad?
Not a cone. Okay. Wow, it's incredible to me that the first result
Oh,
is
that
for
matches.
square pyramid.
Sorry, what?
I'm sorry, I'm ranting.
This does spit out the surface area of a cone in terms of slant height. Amazingly. Not counting the bottom, which we don't want.
Right.
Okay. So that's the proof of concept, right? That this thing actually works if we do it with DQ next. So the force, it's going to be the integral. We're saying that Q is a constant. Well, like, ugh, I'm being this. I guess we should say DQ sub cone for what I put over on the left. Because they already use Q for the point charge. To DQ sub cone over 4 pi epsilon naught. I guess I could have put K. Let's put K. We've been using K for everything else. R squared. From 0 to R prime, right? I think this will be okay. Or I guess we'll find out. gonna say Q sub P.
There's too many R's.
Too many R's?
Too many R's.
Oh, yeah, that's not the same R. You're right. Different R.
Okay.
Maybe some portion of L, I guess, will go in the denominator.
Right. Yeah.
Um,
Sorry. No, that doesn't. No, it does. Except it should be squared.
sure. And then we could call that LR over sine theta. I guess. Sigma 2 pi r dl. We follow the steps from the last one. Oh shoot. These other constants come out front too. Oh my god, that's a whole mess of constants. 2 pi k q sigma. Started the whole alphabet at this point. So we have an r. We said dl is dr over sine theta? Is that what we said? Yes. And that L squared is R. Oh god. Bots, go away. R squared L is equal to R over sine theta. Okay. And that's something we can integrate? Q sub P sigma 0 to R prime. We're making the sine theta as a constant, right? Yeah, we are. I can come out front.
Right.
Is that 1 over R, dr? Ooh. Radian ln? I guess that's what we get. ln. We can do parentheses. We don't need absolute values. Oh wait, ln of 0. That's not good.
What have you done, Don? You've broken the universe.
I did.
He actually took the log of 0. Oh my god.
Yeah, that's diverging, isn't it?
Have we looked at the solution, Don, to get a sense of just what is required, like
Yeah,
as a volume of work sense?
I can do that.
I'm just curious, personally.
587.
Something I tried to do alternatively was work just with the area of a cone, in terms of the length, the slant length,
Okay.
instead of the radius, and seems simpler, but I'm just curious. And I don't know if it's taken me towards the right answer either.
Hmm. Oh. Okay, well, off the bat, I can see we should, for the vertical component, we wanted cosine theta. Oops, I messed that up. Wait, no, but R is L sine theta.
I agree.
Right.
So why are they using cosine? Let's see.
Well, I mean, so far this is just F. We haven't bothered computing the correct component.
Oh, we should stick a cosine theta in front of this at whatever we get at the end. Okay. Is the vertical component of the force due to a small piece of charge dq in the ring is q dq cosine theta over 4 pi epsilon naught x squared. Okay, so they call x the slant length.
That's kind of how I derived it too. What page is this on again?
587, right? It starts at the bottom. They're integrating. Oh, wait. They also get the integral from 0 to L of dx over x. We did it in terms of R, but they still get a divergent integral. So the force is infinite. It's supposed to diverge. Oh. Okay.
I don't think my solution was walking me in that direction.
Huh. That's kind of amazing.
Well, do you think if, let's say, at the tip of the cone, there's any particular force from a charge, and then you consider a test charge at that point, wouldn't that, like, have infinite force between the two charges? Like the force between two charges just gets really big as the points get close to each other.
Right.
True. Yeah, it is right at the top of the cone. And the book, or the answer key at the end says, in short, for small x, which is the slant length, the largest of the 1 over x squared factor in Coulomb's law wins out over the smallest of the x factor in the area of a ring. So I think maybe because it's a surface cone and not a filled-in cone, like we only have a factor of r from the circumference rather than a factor of like r squared from the volume, or r cubed, or whatever it's supposed to be. Huh. The truncated cone. Oh, so for part B, we can expect a finite force, though.
Right.
That's kind of cool.
Not really sure how to interpret that, but
I assume the situation just wouldn't physically happen, so I'm not trying to question it that much, I guess, or... I guess you could really, like, this is just the force at the tip of the cone from all the other parts of the cone. If it's being held together, I guess it's from some other force that is not electrical.
I think you could think of it like it would take an infinite amount of work to get a charge of opposite charge into that spot. So you think of it that way.
Okay. Yeah, I think it's the same thing. Would you all want to try like part B and then maybe wrap things up there for the first session?
Yeah, I'm hoping we can use that same integral.
Hopefully.
It's a different bound, please.
Oh yes, it wouldn't be from 0. Oh yeah. Because that would just give us ln of a constant. I guess L over 2. And there is for what angle theta is the force maximum, which I think is what I was saying before. Or Milka. Gave some thoughts there. See, I think this is going to be the same integral, but instead of 0 for our lower bound, oh god, we're out of room on the whiteboard. I guess I'll do it right to the right there.
There's
And I guess we can calculate the force in the y direction to make Fembox happy. Put a cosine theta on it. Instead of from 0, it'll be from, they're saying L over 2. Keep Fembox happy. L. Oh yeah, I didn't put bounds on my first integral, did I? Oops.
looks like I think so.
K Q sub P dq C or L squared. If you want to derive something, I would say no. Yeah, this equation we are deriving instead of differentiating. I'm just gonna skip to the or skip a couple lines and just reuse the work from last time. Sigma cosine theta sine theta. Oh, what is L over 2 in terms of R?
Currently r prime over 2. Yeah, similar triangles.
Oh, that seemed way too simple, but you're right, yeah, similar triangles. One over R dr. Ugh, there's too many constants, dude. K, Q, P, sigma, cosine theta, sine theta.
Well, this is kind of interesting, though. Milton Horns had said that theta equals 0 would give the most force, but then sine here would be 0. So then the force in the y direction would be 0.
Oh,
If this equation is to be believed.
that is a big if. Yeah, because there's the cosine theta and the sine theta. I remember seeing a cosine theta, sine theta in the answer key as well.
Would that make pi over 4 be the best?
Maybe. That's a good point. Oh my God.
Probably going to depend on Q, which is also kind of funky.
It's really just ln of 2.
Really just ln of 2, yeah.
Huh. And
We got a sine 2 theta in there.
that's weirder that the R primes go away and there's no L's. Oh, yeah, you're right. Oh, aha, that's a good catch. I ln2. We're just collecting every irrational number we can, I feel like. I ln2 k q p sigma cos no sine. 2 theta. Which would or theta equals pi? No, sorry, pi over 2. It's a 90-degree angle, which would be 2 different cannons both pointing into it, right? Like it'll be not even a cone, just 2 line segments on either side of it. What did they cancel?
Wait, sine is maximized at pi over 2.
Oh, so theta equals pi over 4. Okay, never mind.
Nailed it.
Oh yeah, nice photos. As the area decreases, the charge will decrease too because the surface charge density is constant. Oh,
Got it.
huh. That's kind of neat. Yeah, sorry, I was like thinking about this. Like, it feels nice that we're able to actually like get through a good, like, I mean, it's only 3, but that feels like a good number of questions.
Yeah.
I should make sure it vaguely matches with the book. Yeah, they can a factor of ln2 as well, sine theta, cosine theta. It's maximized at theta equals 45 degrees. The force correctly equals 0 when theta is 90 and when theta equals 0. Because of that constant density. It's independent of L. That's, yeah. Imagine scaling this sector by 5. Oh, okay, so L disappears because if you, the more you scale up L, the bigger the gap gets for the top part of the cone. So like cancel itself out.
Yeah, okay.
Even though there's more charge. Okay. The problems in this book have some bite. I found the next one a lot of fun. Ooh.
Yeah, the next one does look fun, but I'm gonna call it.
Yeah, we can wrap it up there. So I think critical, it's gonna have some math questions that I want to be able to help them out with if I can.
Cool.
Thank you both so much for hanging out and helping out with these problems. This was fun. Yeah. So I'm thinking like I'll kind of be doing these every Saturday. So both you and Anosis around are welcome to hop in whenever you're around and you feel like it.
Probably will.
Sounds good. And I'll put the I can get this whiteboard and put it in the chat as well for the reading group. Copy.
One question before we break.
Oh,
What's
yeah.
the R prime in the final solution? Is that not dependent on L? Somehow?
It is. Yeah, it's L theta, sine theta. But it doesn't show up in the final answer.
Oh, okay. That was part A, right?
Yeah.
Yeah, ends up canceling out whether they do R prime or L. Awesome. I guess I'll see you both around. Unless there's anything else, but yeah. Bye.
Come on. Finally. There it is.
There. Oh, yeah. Okay, actually, wait, I can just go. Oh. Okay, good. My mic is being picked up. Okay. Let me get the links again in chat to their streams. That was a ton of fun. Thank you both, and thanks everyone for who was hanging out in chat too. Milk, $10. Anyone else? Mic is intermittent. Oh no. Is the mic okay now? I can maybe hear myself. Let me turn that on. Better now? Okay, cool. So yeah, thanks so much again for everyone doing that. Oh no, I didn't set up my camera quite right. There's a little glare from my light on the whiteboard. Okay, I'll figure that out in a second. Sorry, it's going to be to get things like switched over to get into math mode. For questions 1 through 3 of chapter 1. Okay, let's get the title and category switched. Answering math questions. Yeah, math mode engaged. And internet. Math. So let's add critical in chat. Ooh, critical has some integrals. I'm probably gonna try some of the other problems on stream too, because since there's 80, I'm sure we're not gonna get to all the problems as a group. So oh, you know what? Let me see if I can reposition my camera just a little bit. No! My headphones just, oh, my cords got tangled, and I dragged my headphones on the ground. Ugh. Sorry, there's gonna be a little bit of wobbly. Ah, God. Come on. I wanna... Okay, there. I have to do that very gingerly before every stream. It's not bad. Okay, it just annoys me when there's that little bit of... It's still there, but it's at least a little bit better. Let me ping critical on Discord as well. I need to switch my YouTube title as well. Let me do that. If nothing else, we can still solve critical's problems and let them check the VOD or something, or type up answers for them. Get some music going. Where am I storing this stuff? There. Okay. Debating, should I just start answering these even if critical's in here yet? I think I will, because it's possible critical had to like leave or something for the day. So let's just get started on. So first off, we have these two integrals. So we're gonna be integral of e to the negative root y dy. Is that possible? Some weird like Gaussian integral. But not, I guess. I wonder if this is going to be proving convergence or divergence of the integrals rather than actually integrating these, because the other one is going to diverge, right? Yeah, it should. Hmm. I'm gonna put that first one into Wolfram. Like, I'm kind of... That doesn't seem possible to integrate. It's not easily possible to integrate. No, I'm just bad at integrating. Oh, I get it. All right, we can integrate it. Hey, Caceratops. How's it going? Glad to see you. Yeah, it'll be a U sub, and then we're gonna have to integrate by parts. E to the minus root y dy. All right. So yeah, we take u equal to root y. Du is what? 1 over 2 root y dy. So when we plug this in, we're gonna get 2 root y. No, the bounds are still fine as they are actually. Oh, root u. Wait. Oh. Why is this weird? Oh yeah, yeah. Okay, I remember now, because we're gonna have to sub again. There we go. E to the minus u du, and then conveniently u is root y, so this root y can be subbed on as well. 0 to infinity to u e to the minus u du, and that's an integration by parts. I shouldn't have used u because I'm gonna use it for integration by parts. Like the setup? Ooh, awesome. Yeah, it's been slowly evolving over the year and a half or so that I've streamed. It's still not perfect. Like, I want to get some better lighting, but that's kind of like my next like project. So let's say v equals... I'm gonna put the 2 out front. I know I'm gonna forget about it though. dw equals e to the minus u du. So dv equals du, w equals minus e to the minus u. All right. Minus u e to the minus u plus, because it's a minus, e to the minus u du. 2, don't forget it. Minus u e to the minus u minus e to the minus u evaluated from 0 to infinity. We don't have to bother on subbing because the bounds still work. Conveniently bounds. Yeah, exactly. So this one should converge. No, I don't know. Yeah, it's going to converge. Minus u over e to the u minus 1 over e to the u minus, I didn't see it like written out though, so 0 times e to the 0 minus e to the 0. So that by L'Hopital's is 0. That's 0. That's 0. We get negative minus 1, which is positive 1, so we just get 2. Wow, that's kind of a simple result. It's just 2. I want to plug it into Wolfram Alpha. That's almost like too nice to believe. It comes from such a weird place. Why do they have a negative sign in front? Oh, well, that's probably fine. I'm just gonna do Wolfram with the original integral. I had minus u minus 1 in my expression. Oh, fair. Yeah, okay. That's probably it then. That's the weird thing. Using Wolfram Alpha is that your answers aren't always in the exact same format, so you have to figure out if they are the same. Oh, hey, yeah, you just get 2. That's crazy. This thing is 2. Like that's just... It's kind of hard to believe, honestly. How does the graph look? E to the negative x. Or negative root x. I guess that makes sense. I don't know what I was expecting. Yeah, same pen box. Okay, I guess that's what we get though. This second one should be much more direct. 1 over x from 0 to 1. All right, that we can just integrate directly to get ln absolute value of x divided from 0 to 1. So ln of 1 is 0. Zero from the right. I shouldn't reuse x. I should use t or something. Sue me. 0 minus negative infinity. It just diverges, right? Which geometrically makes sense because whenever x blows up, like the area in there is unbounded, so I think that answer makes sense. I dropped an ln there. I did drop an ln there, you're right. I was so preoccupied with remembering to do a plus or a minus for the limit that I forgot the ln. I mentally had the ln there, which is why I said it's negative infinity, but you're right. Oh, you do ln with a curly L? That's not a bad idea. I never had the mix-up for ln though, at least. Once I started taking multivariable calculus, I did start writing my z's with the dashes in the middle because they look too much like 2's. And for other situations, I do write L's like the curly L. But for ln, I haven't felt the urge. Do you do the curly L for limits? I guess that's the real question. I have like absolute value of n. Oh, that's fair. In the curly, I guess it's like a 1 or absolute value. Yeah, that's fair. For a limit as well. Interesting. So this for limit, you have like x approaching 0 part. I should have taken screenshots of the whiteboard. It's the ln1 or absolute value of n. Fair, yeah, it does look a little like absolute value of n on that first one. I thought I've always written it, and I'm too stubborn to change my ways, I guess. Let me, I guess, get a screenshot so I can send these to critical. Sorry for double me. Take a screenshot of what's on the board now, and I'll quickly open up my VOD. So everything's different when we started teaching. That's fair. Yeah, when you're teaching, that does kind of change things. It's free teaching, and you get what you pay for. That's how I'm gonna justify it. Okay, got my other screenshot. So wait, I sent that 15 minutes ago. So 15 minutes ago in the VOD, it'll be about 2 hours, 30 minutes in the VOD. Okay. Oh yeah, the T's. I need to change my T's. I don't know what to change them to though. I guess maybe give them a little curly thing on the bottom. Because I definitely get my T's mixed up with plus signs. Like I have made that mistake multiple times before. Okay, I just sent critical my work. Just scroll a bit? Okay. That's smart. And your eyes, true. Or we just need more symbols. Okay, that's a lowercase L. Oh, yeah, it is oh, yeah, curl your L's. I mean, for some reason, the lowercase I somehow matches a math symbol, but it doesn't. It really doesn't. Like, oh, of course, yeah, I also looks just like something, but not really. We might do some algebra then, if there aren't questions from chat. I'm not missing anything, right? There's nothing in the homework help forum. In math discussion, there's nothing. Yeah, I think we're okay. So yeah, I said I would read chapter 4 off stream, but I was too busy reading chapter 1 of Electricity and Magnetism multiple times. So I didn't get around to actually reading through chapter 4, so I guess we'll do that on stream. I guess we'll do a little bit more. I think last time I tried to do this, I just got off track with talking to chat, which is also fun. Oh, true. Yeah. Saint was in that person's name somewhere. Oh yeah, so Penn Center is doing an abstract algebra reading group. And I completely agree about the panic. Because yeah, in college I took linear algebra, not knowing what it was about. I'm like, oh, it's algebra. This will be easy. I know y equals mx plus b. And then I actually got into the first day of class and like, oh my god, this is not what I thought it would be. And then I saw a class in like, you know, the register or whatever called abstract algebra, and I was like, I am not even gonna think about taking that. But since Penn Center's been running a reading group on this book, I'm like, I really should try to learn it. Which yeah, by the way, Cassandra, I guess I haven't seen you stream math in a super long time, but if you're ever interested in like more like math stuff around on Twitch, there's a whole little community of people who do stream math. Obviously, like no pressure and do whatever you want, but it's kind of like a cool thing that's I guess like has been created, this little like community. You love abstract algebra, you really need to learn more of it. I'm still waiting for it to get cool, I'm gonna be honest. There's been some like neat facts that we found, but like I don't know, this abstract algebra is just too dang abstract. Awesome, yeah, and yeah, even that like Enigma bot is something that's in all of our channels there that just a member of the community wrote to like kind of unite our channels a bit more. And also did AMC slash. Oh, true. I remember. Yeah, that's what you're doing. Well, hey, if that's a possibility for the future, and who's interested in that should give Triceratops a follow. And also, he does some cool like Baldur's Gate 3 stuff, Inscription, and probably other things too that I'm forgetting, but that's the first person who ever rated me, so. Yeah. Oh yeah, cheese. Um, Cyclic if there's an element A and G. I know I already read this part, but it's been, I think I read it like last week, and I got maybe 3 paragraphs in, and I forgot what those 3 paragraphs said. Yeah, so it's cyclic if if the entire group has a single generator. At least one. So the set of integers under addition have 1 and -1 as generators. And then z sub n is generated by 1 and -1, which is n minus 1, which the book did it, like it kind of hinted at that in some previous problems in the other chapters. Okay, these aren't necessarily the only generators though for z sub n. They just are always going to be generators. Okay. And we're seeing this example the last time I tried to read through this. And I thought the pattern is that these are all prime numbers, but it might just be that they're all odd numbers. If we had or maybe they're all relatively prime to 8. I feel like this is something that we worked out in a previous problem, like with examples, but is it relatively prime or is it odd numbers? I imagine it to be relatively prime, but let's maybe take an example with if we do integers mod 9, what generates that? Oh, you know what? That's generated by 2. So I think it's relatively prime. The only thing that doesn't generate it is 3 and 6. Okay. Never mind. Yeah, I think it's gonna be relatively prime for integer addition. It's relatively prime? Okay. Oh, have you already like studied algebra? I assume that you were like me and you had avoided it, but I never like formally studied this. U10, which is integer multiplication mod 10. The set only consists of relatively prime numbers. You did more number theory than abstract algebra, but there's overlap. Oh, okay, fair. Yeah, there's been a pretty decent emphasis on number theories so far. A lot of like division algorithm and GCD stuff for Matt's wheelhouse. So they show that 3 and 7 both generate U10. 9 is not good because 9 squared is 81, which is 1 mod 10. Okay. They give U of A as an example of something that's not cyclic because none of these generate the group. Okay. Right, and I think, okay, now that I see this, I think when I was last reading, it was somewhere in the middle of this proof. Or maybe I got to the end of these corollaries. I'm not gonna worry about the proofs right now, because I know I've read through them once and I don't care about them that much. So theorem 4.1, criterion for a to the I equals a to the j. If a has infinite order, then a to the I equals a to j if and only if I equals j. If a has finite order, then a to the I equals a to the j if and only if n divides I minus j. The proofs in this chapter, like the actual questions or the actual like understanding, like this proof right here and the ones after it? What I'm looking at right now? Okay. I think this proof, I was like, this part of the proof is something that Zone Ranger already showed me at one point in the context of a different problem, but it's the exact same logic. So I remember being okay with this part, but I don't remember what. I felt about the other parts, but I'm not going to worry about it that much right now. I've used up most of my brain power for the day on the electricity and magnetism stuff, so just get to the good parts. The order of A is equal to the order of the subgroup generated by A. A to the K equals E implies that the order of A divides K. Yes, we've been kind of using that already. Between AB and A times B. Right, this is only true if the two terms commute. So it seems like this is, maybe it's not, but this feels like an important idea here, which is multiplication in the group generated by A is basically addition mod n because of the exponent rules with how the powers add. And for infinite order, it's just addition in Z. Okay. Isomorphism there. Oh, yeah. True. Okay. Yeah, I think it's this chapter, another chapter, and then isomorphisms. Yeah. Actually, only one cyclic group of each order. Oh yeah, Z sub n and Z serve as prototypes for all cyclic groups. Algebra say there's essentially only one cyclic group of each order. Oh, and they literally say isomorphisms here in chapter 6. All right, so theorem 4.2 says the subgroup generated by a to the k is equal to a to the GCD of n comma k, the group generated by that. I assume n is the order of the group generated by A. And so GCD of nk, yeah, that's like if you have a group of order 9, if you take 6, it's gonna be the same as the group generated by like a to the third, as a to the 6. Okay. I'm thinking back to my U9 example that I mentally thought of a couple of example problems ago. The order of a to the k is equal to n over their greatest common divisor. Okay. That's what, like, the title of, they just title the theorem what the theorem actually is saying. They really phoned in the title of this theorem, I guess. It's a way to get your head around these nice theorems. Try and slap some numbers in there. Yeah. The more garbage theorem titles. I've been taught about the Harry Ball theorem, which I actually, you know what? I think that one is anything but garbage, though. That's at least creative. This one is just, you know, meh. It's a classic, yeah. Can you demonstrate us the Harry Ball theorem? Hey, Nikas. Well, the demonstration of the Harry Ball theorem is not nearly as risque as you might think. It is an actual math theorem that seems pretty dry, but it has a fun title. Therefore, to allows us to easily list the elements of cyclic groups. A comb and a coconut. Exactly. A visual learner, hope there'll be this one hairy ball. The coconut model we'll have to do on Twitch, unfortunately. Yeah, unfortunately. The video on OnlyFans. Yeah. I mean, it wouldn't take that long to put together. The video, at least. The OnlyFans, I don't know. Tomorrow. How about that? Easily list the elements of cyclic groups. It's gonna be like $1 million though. Gotta pay. Send you on Discord so you can do quality check. I don't know. The orders of elements of a cyclic group in cases where the elements are inconvenient to work with. Orders of elements in a cyclic group. Now watching OnlyFans video about hairy balls. Pay for the Poincaré Hop theorem? What is that? I'm probably not pronouncing Poincaré right. Is it Hoff theorem or Hoff? It's a special case of? Oh, interesting. There is no smooth vector field in an even dimensional n sphere having no sources or sinks. Wait, topology, like, I didn't know topology says anything about, like, vector fields like that. That's a little I know about topology. I guess it is differential topology. Hmm. All right, see you, Nikas. Thanks for hanging out and talking about hairy balls. Topology of smooth manifolds. Oh, I see. What is like a coboardism? What is this? It's just it makes me uncomfortable to look at. But I can't stop looking at it at the same time. This looks like a belly button or something. I don't know. Think about vector fields relate to the topology of the manifold. And that's kind of interesting then. I like vector fields. Okay, anyway. I can't stop looking at that one image. I don't know why. It's weird. It's just a manifold that connects two others. So the others are the boundary. Okay. I wish they drew it in a different way than I guess. I mean, I've heard the term manifold before, but I don't even know what a manifold actually is in the first place. I think it's related to the idea of like going from like a 2D projection into a 3D object, or like, you know, from a smaller dimension to a higher dimension, something like that, but I don't know exactly. That locally acts like Euclidean space. Oh, okay. Oh, okay, yeah, because if you're close enough to the sphere, it looks flat. Oh, you know what? I think I did read this off stream because this problem looks familiar. They made a mistake. They made a mistake in this one. The GCD of 1,000 and 185 is not 20. This example problem threw me off for a long time. I was like, wait, why doesn't that match with the answer I got in my head? They messed up. They messed up this factorization here. 2 does not go into 185 at all. Yeah, I'm trying to get into the habit of muting for that more because I listen to my VOD when I drink water and it's strangely loud. Like me gulping. So I started to mute myself. Smooth manifold is a manifold with a bit of extra structure so that you can actually talk about derivatives. Oh, okay. Is that 340? Okay, I think this is 5 times 37, 185. I wonder if is that 4 times 5 is 20. 20 times 17. 20 times 17 is 340? Oh, it is. Yeah, I made the exam problem was originally with 340 instead. What's the point of this again, though? So I do remember reading this, but I forgot what the point of it was. Let me start from the easier example. You find the subgroup generated by 26, you find the GCD of 30 and 26, and then you know it's the same as the subgroup generated by a squared. Okay. And then you can do it, and then it's more helpful for bigger numbers like this. But same process. So for this one, that's actually correct, I think. 1,000 is 8 times 125. Sure. 400 is... Oh, what the heck is that? 16 times 25. Which is 80 times 5, which is 400. Okay. So the GCD is 2 cubed, 5 squared, sure, is 200. Okay, I mean, those numbers are nice enough anyway, but I guess that helps. Okay. The order of an element divides the order of the group. Okay, yeah, we've like observed this, but this is the actual statement of that. So next error, all cube equations have at least one solution. One real solution, yes. Hey, Miami Dolphins. How's it going? The solution might be irrational, but it should always exist. Oh, just for any finite group. True. I guess maybe for infinite group, depending on how you want to say divides. Oh, that's a fair point. Caceratops, yeah. I mean, technically everything divides infinity though, right? Besides infinity. I don't know. Okay. That gets a little stupid then. I kind of interesting they add the word cyclic in there. See, we definitely observed that it doesn't need to be cyclic in previous problems. Really, with complex coefficients, you can get a real solution? Or you always do? I have no clue. I've never looked at polynomial with imaginary coefficients. I don't know how they actually work. Oh, good point, yeah. X minus I cubed. Touche. All right, so like restating what we've seen before. I'm good with that. The next two corollaries are important special cases of the preceding. We have corollaries of corollaries? Okay. Calculus real coefficient have at least one real solution. Oh yeah, IVT works. Oh, the conjugate pairs thing. I guess once things get imaginary, you don't need that. Well, we still have a conjugate pair and then one other. No, I guess not. By the same example that Triceratops are already posted. Okay. Proving it is fun? I have no idea how you prove it, to be honest. I saw a video on the proof for why there's no quintic equation. And that was kind of crazy. Like even in the distilled like version of a YouTube video talking about a proof, I still like had a hard time understanding it. Coefficient consists of combination of natural, rational, or irrational roots. Or wait, natural. Okay, yeah. Can a solution be such that it can't be expressed as some combination of those? I think no, or that's the whole idea of transcendental numbers, right? Every real solution should be expressible with regular, like rational and irrational, well, with integers, rationals, and roots. You'll never get pi unless you have pi as a coefficient already. That's my understanding at least. So, and since Well, I don't know how good that like line of thinking is, but actually, yeah, the cubic equation should guarantee you that you always get something expressible with roots. Yeah. That's a much better way of saying it. Oh, is it not that hard to actually prove the conjugate pairs thing? The exponential form of a complex number helps. Somewhere you finish abstract algebra, you want to be looking at the Galois group. Yeah, the video mentioned Galois groups and kind of like using the idea of it without actually naming it. Sorry, yeah, there's a cubic equation. And I think that the existence of that should be enough to guarantee you that your real root is always expressible with just normal numbers and square roots. Ah, depressed cubic. Where is it? General cubic formula. Oh yeah, it's so nasty that they name a bunch of different like little subconstants to make it not take up the entire width of the page. Or some Galois theory in your master's year, you weren't prepared enough going in. Oh, fair. You show that fz bar equals fz minus, or... Oh, f of z bar. Okay. But if we're interested where... Wait, maybe I need to write that on the board to actually understand what's happening with that. Goodbye, eraser. F of z bar is equal to f of z bar. But I'm interested where f of z is equal to 0. I'm not sure like how that fact helps us if we can prove it. Oh, I get it, because 0 is itself conjugate. Okay, yeah, okay. I just need to think for more than 45 seconds, I guess. Turning the exact value for sine of 1 degree. You know sine of 3 degrees, you know sine of 3x. Really? I see a cubic with sines.
I bet you Wolfram Alpha can do this. But yeah, as an output, sine will always give you, maybe I see now where your question is coming from. The output of sine is always still like with roots, and I mean, can sine of something equal pi? No, because yeah, pi is out of bounds. Well, maybe it can be, I don't know. I'm making too many guesses right now. So you're solving 0 equals 3 sine x minus 4 sine cubed x. Oh wait, sorry, of 1. Wait. Why am I getting stupid? 4x cubed, alright. We can do it like that, because I can feel my brain power quickly fading. But it's like, this is sine of x is equal to -1, or sine x equal to 1/2. That seems too simple. You know sine of 3, and you're trying to get sine of 1. So sine of 3 is just a constant. So I don't think it's this, necessarily. I think we have -4. We're trying to isolate sine of 1, which I guess it would, yeah, like that. What syntax is, yeah, okay. So yeah, Wolfram Alpha wouldn't do it with sine of 1 like that then. That looks like a cubic equation result right there. Oh, no, never mind. That's sine of 3 with roots and all that. Never mind. Which one of these do we want? I don't know how to interpret 3 distinct real roots. The second one? I think we just take the arcsine of that if that's the case then. Only plausible? I'll believe you there, I guess. But, I mean, it's not going to actually be 0.017. You have some crazy square root thing is your issue, right? That does get us to be 1. What will the other ones give us? Sort of curiosity. You want the exact solution. Okay, I don't know why that one's like that, but doesn't matter. Oh yeah, it's just too it's too close to 1 or -1. Those other 2 roots. I doubt any free program is going to do that much symbolic manipulation for you. Or okay, so whatever crazy thing you have for sine of 3, like I assume it looks something like that. You can like you can't apply the cubic equations with, you know, -4, 0, 3 in that crazy thing and get an exact solution using these formulas, or it's possible to write it out all in one thing. It's gonna look terrible. It solves that in terms of A. Then plug your sine 3 back in. Oh, okay. That's a nice call. Is Wolfram actually okay with like weird constants like that? That might have helped for the physics part. Yeah, that'll save you some work there, I guess. I assume you want the real one? Not necessarily. I don't know. You might need to like plug it into each of those expressions to figure out which one actually goes with the one we want. Well, it's your y-intercept that you're varying. No, I don't know. I'm not good enough with polynomials there. Yeah, I think what'll happen is when you plug things in, the I should go away. That's my assumption, or maybe it is just, you can tell it's just a real solution. It's based, or, you know, it's this one just based off that. But we did get, we already got 3 real solutions with sine of 3. So I assume there's something about sine of 3 being the value that it is that makes these turn back into real. Yeah. So that's why I'm not sure which one of these is right. But if you're willing to like type it out, or I don't know if to let you it won't let you copy paste that. That's kind of lame, Wolfram. Do the work by hand. I guess that's what you'd have to do. You can use Wolfram in advance to figure out which one of those you want, though, so you don't waste time choosing the wrong route. But yeah. It's just going to be a pain to type it back into Wolfram Alpha 2, I guess. Probably still better than doing it by hand, but still a pain. Yeah, nice call on that, Fembox. You know, I completely skipped over time, but I just now realized that Mega said you need to make the point that f star is equal to f. And that's fair if it's a real function anyway. Wolfram Alpha worked like that, you just tried it and it worked? Yeah, me neither. Half the time when I tried it, or not even half the time, usually when I try to put a random constant in there, like an A, it just like gives me something really stupid. It's like before for the physics, when we had like an H, I was like, let me like just do it by hand because I didn't trust Wolfram to actually do it right. But maybe it would have. For me, these complex numbers, even when all the solutions are real, is what convinced people that the complex numbers were just the fever dream of a lunatic. That is weird. There must be some kind of nice cancellation though, where you get a plus, a plus I minus I, and their coefficients are the same. Does it like to give whole number angles thought for once you wouldn't approximate? I think people will forgive you for approximating on that problem syntax here. I kind of respect not approximating, but that's like when mathematicians do physics. Oh my god. Imagine giving that to a physics professor, an exact answer to a problem like that. Small angle approximation, a whole new meaning. Yeah. Small angle approximations are for wimps. We know sine of 1 degree with the sum formula. We get all the naturals? The sum formula? Like, I imagine like a geometric series. I don't know. Oh, or just like the power series for sine? Oh, dude, this site, it just doesn't work anymore. Oh, with that. Oh, I see what you mean. Okay. I was going down the complete wrong direction with that. Oh, and yeah, I'm not going to try. Again, I'm not going to try to pronounce that. Welcome back though from YouTube. Will you mind explaining a little bit of basic tricks, specifically radians to angles? Yeah, sure. Let me go to my favorite site, Paul's Online Notes. There's a formula for it if you just don't want to think. Does Paul's note not say the actual formula? Because I don't feel like thinking about it for myself. Okay, maybe I'll have to think about it. If you have an angle in degrees, is it dividing by 360 times 2 pi? Yeah. Because 30 over 360 is... Sorry, and I'll rest on the board and do a better job of explaining. I just want to make sure that I'm going to tell you the right thing. 30 over 360 is 120. 120 times 2 pi, or that's 1 over 120. Is it, what's that? Why am I getting that mixed up? Convert radians to angle, to degree. Just tell me the formula. Yeah, sorry, the way that I do radians to degrees and back again is a little bit weird. It's maybe not the way that I would explain it to someone who's like first doing this. What's the formula that I'm thinking of? You'd have 2 pi equals 360 degrees. I guess you could, There we go. To convert radians to degrees, multiply the radians by 180 over pi. That's your like conversion factor, I guess. Okay, so I'm gonna explain the way that I think about it too. Hoao, or I feel terrible. I have no clue how to pronounce that, but. The simple thing, so you say converting radians to angles. Okay. All you do is you take your angle in radians, and you multiply it by 180 over pi. So if they make you convert pi over 4 into degrees, multiply by 180 over pi, the pi's cancel, and then you do 180 divided by 4 is 45 degrees. So that's if you just want something that you can memorize and use, that's how I would do it. What else? But there's not that many. I just had this memorized that pi over 4 is 45 degrees. And so that's why like it's kind of hard for me to like recommend that you just magically have it memorized too. But if like I have the first quadrant of the unit circle just memorized, each part of it. So I know that this bar in the middle goes with 45 degrees and pi over 4 at the same time. I just know that. So if I get asked to convert pi over 4 into degrees, I just think about the unit circle. And I just have it memorized at pi over 4. Or that, you know, that angle is pi over 4 or 45 degrees. So that's how I do it, which, you know, it's just memorization, but that's the actual like formula way to do it for an arbitrary angle in radians. In reality, you usually get given something that's on the unit circle though. Or if it's not exactly on the unit circle, you can convert it into like some combination of things on the unit circle. Like if you do plus and minus different angles. No worries. The website with all these exponents signed of n, but you forget where it was. Oh, okay. And it gets us to 3 degrees. Nice NCR flag, thank you. I love Fallout. Yeah, the triple angle is how syntax error got that cubic. I guess you could do the sum and angle stuff though, like Fembox is saying. Oh, you're doing a... So you're doing 3 equals 2 plus 1, and then doing that addition formula, and then you're doing a half angle? I mean, that's fair. You could do 2 equals 1 plus 1. You will get the same thing though, I guess. That's probably a bit quicker to do the calculations with. Just differentiated the triple angle. Wait, you... I was like, I was trying to figure out, like, what do you differentiate? Oh, God. Point made, you know, it is weird to say that you differentiated that formula. Gotcha. True. Yeah, true. How much more is there to chapter 4? There's at least like 5 more pages. I can't even count that high. It's the end of the good stuff. All right, I'm gonna skip over the proofs, but let's see if we can maybe get through chapter 4, like the reading part of it. I might not stream for much longer after that though. My brain is still like fuzzy from doing all that physics. It's really fun though. Like I want to go and solve some more of the physics problems. Like I don't know if I'll be able to wait until the time to stream next. It's not enough that if you put a group structure on the set of remaining pages, it would be an abelian group. Oh gosh. Dude, can someone write an abelian book where you could go from any page to, I guess, any combination of pages back? No, what would that be? I was imagining a book where no matter which page you turn to, the story still makes sense. But that's not really abelian, is it? You'd have to do like any combination of pages in order. You could read them backwards and it still makes sense. I don't know. Never mind. That doesn't really. Yeah. You know what? That's just stupid. I do. If the GCDs of 2 power are equal, the GCD of 2 powers with n are equal to each other, then their subgroups, then the generated groups are the same and the orders are the same. Okay. So a to the j, or the group generated by a is equal to the group generated by a to the j if and only if they're relatively prime. Oh, this is what I was wondering before in that other example. So yeah, if in z sub n, or in addition mod n, it has to be relatively prime to n to be a generator. So they get the, oh yeah, so the point of this is that you can, of corollary 3 is that you can easily get all generators of the group. So with u of 50, which is not trivial to do by hand, they do by hand that the order of u of 50 in general is 20, and that 3 is one of the generators. So every other generator of u of 50 is going to be every element of U50 of 3 to a power that is relatively prime to 50. That's the pattern. Okay. Yeah. It's a nice little way to simplify work. Subgroups of cyclic groups. Fundamental theorem of cyclic groups. Every subgroup of a cyclic group is cyclic. The order of the group generated by A is n. The order, yeah, is a divisor of n, plus a divisor k of n. Exactly one subgroup of order k. Oh yeah, I feel like I've read this before too. Maybe, I think it was somewhere in this proof that I stopped reading though. This proof was, oh wait, it ends there. I think this one was a little bit hard to wrap my head around. Exactly one subgroup of order K is kind of crazy, isn't it? Didn't they? Oh, it's not cyclic. I'm gonna look back at some of the examples from earlier. Oh, because they're going to be the subgroups are going to be equal to each other, so they're not actual distinct subgroups. You can have multiple generators, but they're going to make the same subgroup anyway. That's why there's only one of each order. Okay. Generated by 3 in order. You found a good to write out the elements generated by 3 in order in a list. Yeah, I'm still trying to figure out what you're saying. Positions that are relatively prime to 20. Oh my gosh. Is this specifically about like the last part of the fundamental theorem here, or is it just like, or is what you're saying completely unrelated, or is it about the entire theorem? Or is it just talking about the problem, not even getting to the theorem yet, I guess? I'm asking about a whole bunch of questions that are kind of the same thing. These questions have the same generator. It's the previous theorem. Okay. Sorry, I was getting mixed up because I was thinking about this whole part of the theorem, and then I saw your comment, so I was getting confused on how it's related, but it's not. Okay. Resistors that are relatively prime to 20. I see. So yeah, the order is 20, and we're really choosing out the numbers that are relatively prime to 20. So yeah, 1, 3, not 4, 5, 6, or 7, or not 4, 5, or 6. Yes, 7. positions. You know what? I think you're saying, I think I'm making what you're saying too simple, and there's one's generated by 3. Okay, you know what? I think I just need to see the actual elements of the group. It'll be a little bit annoying, but let's start on the elements of U of 50. One, 3, not 4, 5, 6, yes, 7, not 8, yes, 9. Every power of 3 is going to be in. Not 10, yes, 11. Not 12, yes, 13. Not 14, not 15, not 16, yes, 17, yes, 19. 21. 23, 25, 26, 27, 28, 29, 31, 33, 34 is not, 35 is not, 36 is not, 39 is, 41, 43. Means that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So 3 more. Not 44, not 45, not 46. Yes, 47. Yes, 49. I'm missing one. That's only 19 things, isn't it? I skipped 37. Dang, I did. You're right. I think I can squeeze 37 in. Okay. So that's U50. U50 equals 20. The subgroup generated by 3. I mean, we expect the entire group. It's just a matter of like the order, I guess. So we start with 3 to the 1 is 3. 9, 27. Now we're going to cycle back around. So we're going to get 81. Because 9, 10 to 9. And 81 mod of 50 is 31. 31 times 3. 93 is 43. This can be a huge pain, isn't it? I mean, 43 is the same as -7. So -21 mod 50 is 29? Hey, SPQ. Uh, 29 is like -21, which times 3 is -63, which is 37. 37 is like -13 times 3, -39, which is 11. Uh, 11 times 3 is 33. 33, that's 99, which is 49. 49 is like -1. Which is like -3. Which is, or 47. Then negative 3 times 3 is like negative 9. Oh god, 41. Which is so... Negative 9 times 3 is negative 27. Which is 23. I feel like I'm doing pretty well in the mental math right now. 23 times 3 is 6. That's 69. Oh, dude, that's 69. Hell yeah. 19. 19 times 3 is 57. 7. Yeah, Phobos, it's algebra time. You want to check that 3 is a generator, you don't have to check all the powers. Yeah, I'm doing this annoying arithmetic just to kind of demonstrate what the corollary is actually saying. But yeah, the entire point is we don't have to do this, but it's probably instructive to actually do it. $63, which gives us 13. 39. Are we almost done? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 2 more. I'm going to the third line. I should have just written those 2 up there. I'm not doing that though. 39 is negative 11, which is like, so multiply by 3, negative 33, which is 17. 17 times 3. 51? That doesn't sound right. 41. That sounds right. No. That's not right. 17 times 3. It is 51. Which is 1. Okay, yeah. Oh, a deck of cards is 13 times 4. Okay, I was thinking of 17. Okay, that's why I thought I was wrong. I was thinking about a deck of cards. Everybody blame Fembox? Yep. This is your fault, Fembox. All right. No, so the point of doing this is that we can now look down the list in every position that's relatively prime to 20. It's also a generator. So 3 is a generator of U 50. 2 is not relative, or yeah. We're counting from 1, we're not counting from 0 because this isn't computer science. So 2 is not relatively prime, 3 is relatively prime, so 27 generates it. 4 is not, 5 is not, 6 is not, 7 is. I assume this is what the idea is. Aren't we saying, is that even the right idea? They're saying 3 cubed, 3 to the 7th. Okay, yeah. This is it. Okay, good, yeah. Okay, you're right. 8 is not, 9 is, 10 is not, 11 is, 12, 13 is, 14, 15, 16, 17, 18, 19. 1, 2, 3, 4, 5, 6, 7, 8. And the book has 8. Okay. So yeah, we're just basically manually verifying this list here because the actually looking at it in a list like that, it's kind of nice to see which ones don't get included. Maybe more like the visual way. Symmetric pair of inverses mod 50. Oh, yeah, the actual position in the list. If you split in half, those halves are symmetric. If I wrote my list a bit better, it would have been it would have been more visually clear. But like, these two are pairs. Those two are pairs. Those two are pairs. Those two are pairs. So 49 is in the middle? Is that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? Okay, yeah, it's the 10th one. Wait. Okay, so the thumbnail theorem of cyclic groups. And thanks for the help with guiding me through that box. I'm going to skip over the proofs because I'm getting tired, but see if we can at least 10a plus 7, 10a minus 7. I feel like there's some simple explanation for that, but I can't find it. See, I'm not sure. Seeing the proof there. Returning from to our discussion. As order 30 may conclude. Where M is a divisor of 30. And so, yeah, like this list doesn't include a to the fourth because a to the fourth would it be the same as, yeah, it would be the same as a squared. For each positive divisor k of n, the set generated by n over k is the unique subgroup of z sub n of order k. The only subgroups these have been. Okay, fair enough. Generates the subgroup of order 9 in Z sub 36. You do that 36 over 9 equals 4 is one generator. It's everything that has a GCD of 1 with 9. Interesting. You know, I feel like I'm getting too like tired even to do this last bit. Yeah, it'd be cool to finish on stream, but there's no point in like trying to like push it, I guess. I think we'll just wrap things up here, to be honest. Yeah, so yeah, I'm gonna cut the YouTube stream here. So if you're here on YouTube, I appreciate you. I'll be back on Tuesday. Oh, wait, what's up, Cut Cosmolano? I haven't cut anything off yet. I don't know if I can help you if you have a question, but... What's the no for? Oh, you don't want... Oh, okay. Fair enough. All right, yeah. Goodbye, YouTube.